let us look at continuity. Now, a definition might be in the form that says if the limit as x tends to a number c of f of x is equal to f of c, then the function is continuous. Now, an example might be in this function. Let us say you have f of x is x plus 2. There you have this line. This is the graph of f of x plus 2. Let me make it thicker. Here, this is x plus 2. In this case, this came up accidentally. Okay, in this case, the limit as x tends to a number. For example, 1. As x tends to 1 of x plus 2 is equal to 1 plus 2, which is 3. Alright? Of course, f of 1 is equal to 1 plus 2, which is 3. That came back to where we said if the limit as x tends to c of f of x is the same as f of c, then the function is continuous. I cannot see any number, any value of x for which x plus 2 is discontinuous. I'm not able to find that. So x plus 2 is continuous for all values of x, for all intervals of x. When I say for all values of x, I mean, for example, when x is 2, it is continuous. When x is 1, it is continuous. When x is 0, it is continuous. When x is negative 1, it is continuous, and so on. Intervals, for example, for x between negative 6 and 2 is continuous for all values of x between x is negative 6 and 2. So this is indeed a continuous function. We're going to look at another function. Let's erase this one first. And get rid of the graph. We're going to use a new graph. Suppose we have the function, let's call this g of x. G of x is x squared minus 4 divided by x minus 2. First of all, what would that look like on the graph? Let's use open bracket, not the curly bracket, the round bracket. Open bracket, x to the power of 2 minus 4, close bracket, divided by x minus 2 in brackets. Okay. So, this is the graph of x squared minus 4 divided by x minus 2. Let me make the line a bit thicker than it is now so we can all see it very well. So here we have this graph. Now, is there any point on the graph where there's a discontinuity? Let's see. First of all, if you should take x equal negative 1, let's find g of negative 1. And by the way, let me rewrite this g of x here to make it clearer. It's g of x. Nice. G of negative 1 is negative 1 squared minus 4 divided by negative 1 minus 2. What is g of x at this point? It is negative 1 squared, which is positive 1. 1 minus 4 divided by negative 1 minus 2 is negative 3. So what we have, 1 minus 4 is negative 3 over negative 3, which is negative 1. Okay, so when x is negative 1, g of x is negative 1, which is at this point here. So g of x is continuous at x equal negative 1. Let us try positive 4. At x equal positive 4, what we have is g of 4, which is 4 squared minus 4 divided by 4 minus 2. So what we get is 16 minus 4 divided by 4 minus 2, which is 2. 16 minus 4 is what? 12. 12 divided by 2 is 6. So g of 4 is 6. Let's see. This is g of 4. You go up to the graph, go across, and you see it located at 6. Nice. That's good. So the function g of x here is continuous at g of 4. Let us try g of 2 and see what happens. When x is 2, we have g of 2, and g of 2 is 2 squared minus 4 divided by 2 minus 2, which is 2 squared is 4. 4 minus 4 divided by 2 minus 2, but hold on, 2 minus 2 is 0. What we have here is 0 divided by 0, which is undefined, and it is discontinuous. There's no continuity at x equals 2. Now, at exactly x equals 2, it's not continuous. This function is not continuous at x equals 2. Let me just erase the 4, the 1 for 4. I will concentrate on this one since we found a point of discontinuity here. So, when we found g of 2, we got an undefined answer. 0 divided by 0. Right? If you were plotting this graph using pencil, what you would have to do when you plot this point, you'd have to use an open circle. Right? This point here was continuous, and you could use a dot, a shaded circle, a shaded circle to show that this point exists, but an open circle here to show that this point does not exist. Right? Now, the fact is, the limit as x approaches 2 of g of x, let me write that again, the x part of g of x is equal to 4. Note it says as x approaches 2, right? However, at exactly 2, g of 2 is not defined. G of 2 is not a defined function because you cannot find g of 2. However, as x tends to 2, the limit of g of x as x tends to 2 is equal to 4. So the limit does exist as x tends to 2. But at exactly 2, g of x is not defined. So here g of x is not defined at x equals 2. You could also say any interval that involves x equal 2 is not defined. For example, x, when you talk about x being greater than or equal to 1 or less, let me redo that part. X being greater than or equal to 1 and x being less than or equal to 3, there is a discontinuity at this point, alright? Because you have crossed the x equals 2. The fact is, the function is continuous for x between 4 and 6, because there is no point of discontinuity between 4 and 6. However, there is a point of discontinuity between 1 and 3. Alright, so we see that this function is not continuous for all values of x. We're going to look at a third function, but in a separate video.